Hello, welcome to this week's session of a virtual tour. I'm Natalie and I will be taking you through this week's video. In this session, we'll discuss the different ways electricity is generated along with the pros and cons of each. We will also look at how electricity gets from where it is generated to where it is used, and at the end, a short quiz on how much you think household appliances cost to run in a year. All power stations feed into the national grid, which we'll talk about later in this video. There are over 25 million homes in the UK, with more being built every day, along with businesses and factories that need electricity all of the time. Different power stations use different fuels to produce electricity. Let's take a look at these. Coal has been used for many years in the generation of electricity. It is a combustible black rock and the history of coal mining goes back thousands of years. It became important in the Industrial Revolution when it was primarily used to power steam engines, heat buildings, and generate electricity. The pros and cons of coal include the following. There is a plentiful supply, it's inexpensive, it can be used at any time, and most countries already have this infrastructure in place. However, it is a non-renewable fuel, there is numerous environmental impacts, it has to be mined from deep under the ground, and CO2 emissions can contribute towards climate change. Nuclear power plants are thermal power stations in which the heat source is a nuclear reactor. As is typical of a thermal power station, heat is used to generate steam that drives a steam turbine connected to a generator that produces electricity. Unlike fossil fuels, nuclear fuels do not produce carbon dioxide or sulfur dioxide. They produce large amounts of electricity, it's a reliable energy source, and no fossil fuels are required. However, nuclear waste must be taken care of very carefully with high costs to get rid of the waste. If there is an accident, large amounts of radioactive material could be released into the environment. In addition, nuclear waste remains dangerously radioactive and harmful to health for thousands of years. And like fossil fuels, nuclear fuels are non-renewable energy resources. They will run out one day if we keep using them. Wind energy. Wind turbines work in a simple way. The wind turns the propeller-like blades of a turbine around a motor, which spins a generator, which creates electricity. The pros include that it is a renewable energy source, there are no fuel costs, no harmful polluting gases, and they can be located offshore, reducing their visual impact. But they can be noisy and disrupt local views. They will only produce electricity if there is wind, and they can be expensive both onshore and offshore to install. Pumped hydroelectric storage facilities store energy in the form of water in an upper reservoir, pumped from another reservoir at a lower elevation. It is a renewable energy source that is emission-free and can supply quick electricity almost instantly. But it can only produce electricity for short periods of time only. You must pump the water back up to the top of the reservoir to produce again, and there is high initial building costs which require special location. Tidal power or tidal energy is a form of hydropower that converts the energy obtained from the tides into useful forms of power, mainly electricity. Just like the pumped water storage, it is a renewable energy source which is emission-free. It's reliable as it always happens twice a day and there is low operating costs. But the location must be very specific, marine life can be affected, there's high initial building costs, and it can change the tide levels of local areas. Geothermal power plants use heat from deep inside the earth to generate steam to make electricity, heat water, or provide heat for buildings nearby. It's a renewable energy source, there's no fuel costs and no harmful polluting gases that are produced. The hot water and steam can be used to heat buildings directly, But most parts of the world do not have suitable areas for this energy source. There is high initial building costs and it can be difficult to repair. Solar energy refers to capturing the energy from the sun and then converting it into electricity. As we've seen with the others, it's a renewable energy source with no fuel costs and no harmful polluting gases that are produced. Solar cells can provide electricity in remote locations where there is no mains electricity. But solar cells are expensive and inefficient, so the cost of their electricity is high. Solar cells do not work at night or when it's cloudy and you need a lot of space to run many panels. And in winter, when the demand is highest, output is the lowest due to shorter days. Natural gas power plants generate electricity by burning natural gas as their fuel. All natural gas plants use a gas turbine. Natural gas is added along with a stream of air which combusts and expands through this turbine, causing a generator to spin a magnet, making electricity. The pros include the following. It is the cleanest burning fuel of all fossil fuels, it is an abundant source of domestic energy, and it is one of the main fuels this country uses, and gas turbines are highly efficient. But the cons include that it is a fossil fuel and a non-renewable, it's costly to process, transport and store, and fracking for gas may contribute towards earthquakes. Biomass is plant or material used for energy production. It can be purposely grown energy crops, wood or forest residues, waste from food crops, food processing, or human waste from sewage plants. The pros include that it's a renewable energy source, it uses waste products for energy, it is carbon neutral, and all countries can plant trees to be used for biomass. But the cons, you need large areas of land to grow, the transportation and delivery of biomass relies on fossil fuel power, the construction and operating costs of biomass energy plants can be expensive, and it results in the release of various gases which contribute towards air pollution. Each of those power stations will be controlled by a control room, either located on the site or off-site. But what is a control room? A control room is where the operations of the plant are controlled to ensure that everything is working correctly. This is the nerve centre of the power station. Data from across the plant is fed into the control room, giving unit controllers a view of every stage of the generation process. The information displayed across the web of screens around the room shows data on temperatures, levels or positions of equipment, and enables operators to monitor and adjust activity around the plant. Once power stations have produced electricity, all of these power generators feed into the national grid. Each power generator will produce different amounts of electricity, so it is the job of the national grid to control which power stations are operating, making sure that the UK has the right amount of power. But what is the national grid? The national grid is the system operator of England, Wales and Scotland's electricity and gas supply. It is the company that manages the network and distribution of electricity and gas that powers all of our homes and businesses. The National Grid network is made of high voltage power lines, gas pipelines, interconnectors and storage facilities that together enable the distribution of electricity. The grid ensures that all areas of Great Britain always have enough power. These are the different stages that the electricity goes through before it arrives in our homes. It is generated in power stations. At Drax, the electricity is generated at 23,500 volts, but this needs to be made higher by the job of a step-up transformer, which we will go into more detail on the next slides. Step-up transformers are used to increase or step up voltages. These are used when the electrical power output at the power station is stepped up from 23,500 volts to 400,000 volts for transportation around the UK. The transmission lines are high voltage overhead power lines which are used for long distance transmission of electricity. There are over 4,300 miles of lines across England, Wales and Scotland. The distribution lines which we see near our towns and villages are the lower voltage lines. Most of the poles are wooden. A step-down transformer is used to lower, or step down, voltages. They are located near where the electricity is needed, such as near factories, houses and businesses. It is then ready for the consumer to use. Households in Britain spend an average of £1,137 each year in energy bills. This totals at £520 on gas for cooking and heating, with £617 being spent on electricity. Now it's time for you to guess how much everyday items in our house cost to run. Okay, question 1. How much does an electric shower cost to run in 1 year? Is it £148.15p or £212.84p? Question 2. How much does a dishwasher cost to run in 1 year? Is it £48.84p or £101.32p? Question 3. How much do you think it costs to watch a television for a year? Is it £35.63p or £42.33p? Question 4. How much does it cost to run a washing machine for a full year? Is it £183.93p or £29.30p? Question 5. The cost to run a fridge freezer for a full year. Is it £32.54p or £98.34p? And last question, question 6. How much would it cost if you left a smartphone on charge constantly for 50 days? Is it £1 or £100? And that's the end of this session. Thank you for watching and joining in, and we look forward to seeing you on one of our next sessions.